One small step for man, one giant leap for mankind.
Welcome to an uncensored podcast production. I am your host, Seth Michaels, and for the first time, I am releasing an episode that will be on both of my podcast platforms, History Uncensored and The Science Solution. So, for those of you who listen to my history podcast, I do have another one, Science Solution, as I just mentioned, and vice versa. The reason that I'm doing it like this today is because there is a new piece of evidence that was recently discovered, 2016, a new skull, and it really hits on my very favorite part of both science and history, biological anthropology. You might be thinking, what the heck is biological anthropology? Or if you already know, good for you. But the reason that this is so exciting for me is it's really a crossover between science and history. Biological anthropology, though kind of being remembered for the thing that promoted racism and white supremacy in the 19th and 18th century, is really the study of human evolution. And that's what I want to talk about today. Like I said, for the very first time, History Uncensored and the Science Solution meet in the middle for both science and history, and I'm really happy to present to you this episode. Missing Link, the New Face of History. That was kind of a clickbait title. Anytime we find new pieces of skeletons or fossils that are left over from our near ancestors, it really helps us, it kind of forms this missing link. Missing link is just really kind of a misnomer. Like I said, all of these pieces that are discovered are missing links. So pretty cool. I just want to go over real quick because this episode is a little bit terminology heavy, and I don't want you guys to be lost as I'm explaining anything. Here's some terminology to know. Hominin. Any species of early human that is more closely related to humans than chimpanzees, including modern humans themselves. At this point, it includes the genuses Homo, Australopithecus, Ardipithecus, and Paranthropus. What they do is that these genus can and do change various new fossils are found, which I'm kind of talking about today, with which either add new versions or cast out on existing ones, such as like Homo erectus, Homo floresiensis, Australopithecus, a couple of different ones, but kind of a really interesting timeline. The next one, so that was hominin. The next one is hominid, all modern and extinct great apes. That includes, extinct gorillas and chimps, orangs, humans, as well as their immediate ancestors. These are going to be some of the ones that are kind of more closely linked to pre-human-like ancestors. So that's going to be like Chedensis, and I'll talk about him later. And the last one, really, everybody should kind of know what evolution is, but it's the process by which different kinds of living organisms are thought to have developed and diversified from earlier forms during the history of Earth. It's really basic. I do have a link on my website, historyuncensoredpod.com, if you want to go check it out. Pretty cool. But what is this missing link that we found? Well, the fossil in question was a male hominin found in Ethiopia, which is, that section of Africa is really the place where we find most of these old hominid fossils. There are some claims that this is the oldest known ancestor that we found. That isn't exactly true. It's the oldest known hominin that we found, but it's not the oldest known bipedal great ape that we found. And as always, we can't really say that it's a direct ancestor of ours. There's no real proof showing that, but it does seem pretty obvious that these bipedal great apes are really interesting, and they provide kind of this stepping stone, these missing links to get to where we have come today. What is a missing link? As defined by the internet, a thing that is needed in order to complete a series, provide continuity, or gain complete knowledge. It's something, an example they give is they are the missing link between progressive rock and punk rock. More likely that when I say missing link, you guys would think of this term, a hypothetical fossil form intermediate between two living forms, especially between humans and apes. And every fossil we find from pre-human bipedal remains is a missing link, kind of what I discussed earlier. It provides a record of how we as humans possibly evolved. Huh? That's right, these fossils are amazing and provide a unique glimpse into the life of our early ancestors. Or so we believe. Here's the thing. We don't exactly have, hard proof that they are our ancestors. I mean, DNA has a very short half-life, and when you get into the millions of years, it gets kind of difficult. We definitely share characteristics, kind of more modern homogeneous characteristics, as well as more that are considered more gracile, and then we have the more robust, archaic pieces of these hominins that live. So, the really extended brow ridge and super thick jaws and the way their teeth are formed, bent finger bones, so on and so forth. The bent finger bones really is for brachiation, climbing through the trees, which is pretty cool. Now that I've kind of explained this, you can kind of see that each piece of the fossil record is important to understanding our past. Each piece gives us a clue to the final puzzle, which, to be honest, is probably unlikely that we ever truly know. But that doesn't make their discovery any less exciting. Here's what we do know. That hominins, these Australopithecus anamensis, which is the type that this fossil was, were among the very first great apes to walk on 2 feet. They probably had a kind of more of a bent back. And walking on 2 feet really provided both some advantages as well as kind of some disadvantages, right? Walking on 2 feet frees up your arms for carrying things. Let's say children, or if you need to live a more nomadic lifestyle as the climate was changing during this time and you're going from more rainforest to more of a savanna type environment, you need to be able to move greater distances. The walking on 2 feet is significantly more efficient than walking on 4. There's less energy consumed. That's also why humans are really good, as endurance species, we're really good. We can basically chase prey until they die. That's for another time. But it also has some disadvantages too. Let me ask you guys a question. Do your knees and ankles hurt frequently? How about your hips or your back? Our weight and weight distribution puts a lot of pressure on certain parts of our body, especially in the lower back, hips, and knees. That's a lot to ask of any part of the body. And these would be parts that traditionally seen in the great ape species, chimpanzees, gorillas, so on and so forth, that would also be supported by the arms and shoulders while they're walking around most of the time. It's pretty much as simple as that. Even though we've been, humans have been on the planet for 250,000 years or so, that doesn't mean that our bodies haven't figured it completely out yet, right? That's why there's so much wear and tear in those sections, that core section of your body that provide most of the locomotion or the way that we move from place to place. Especially that lower back. When you're carrying something, there is a lot of pressure on that lower back and those hip joints. I want to get back to the skull, the very reason that I'm talking to you guys about this today. Pieces of bone from this long ago, and I suppose I haven't mentioned it yet, but this skull was found in Ethiopia, and it's dated to around 3.9 million years ago. Hominins have come a long way from 3.9 million years. It used to be significantly smaller than we are now, but So from 3.9 million years ago, and it is very difficult to find any fossil record from really that long ago. That's why Ethiopia and some of these other really dry environments are great for finding these types of fossils, this type of fossil evidence. And it's, like I said, it's really rare. Most bones from more than a million years or so ago are usually only fragments of the whole. We've been pretty lucky with a couple of them, but this find was nearly an entire skull. And the skull can tell us so much about how this bipedal hominin, this ancient human, lived. There's a very rich history dating back several million years all the way up to now, where humans first presented themselves in the archaeological record. I'm going to go over it briefly because it gets kind of confusing, and I'm going to say a lot of names that probably don't make any sense. But I want to talk about the study real quick. Here's the abstract from the study. Don't worry so much about all of the syntax. I'm going to try and break it down for you. It's not too bad. The cranial morphology of the earliest known hominins in the genus Australopithecus remains unclear. The oldest species in this genus, Australopithecus anamensis specimens, of which have been dated to 4.2 to 3.9 million years ago. It is known primarily from jaws and teeth, whereas younger species, dated 3.5 to 2 million years ago, are typically represented by multiple skulls. Here we describe a nearly complete hominin cranium from Oranso Ethiopia, that we date to about 3.8 million years ago. We assigned this cranium to A. anamensis on the basis of the taxonomically and phylogenetically informative morphology of the canine, maxilla, and temporal bone, jaw, forehead, and tooth. This species thus provides the first glimpse of the entire craniofacial morphology of the earliest known members of the genus Australopithecus. We further demonstrate that A. anamensis, Australopithecus anamensis, and Australopithecus afarensis differ more than previously recognized, and that these two species overlapped for about 100,000 years, contradicting the widely accepted hypothesis of anagenesis. This is really interesting. It's saying that these two species, which we had kind of previously thought of as like one led directly to the other, well, Australopithecus anamensis is quite a bit more different than what we expected, or what we expect from Australopithecus afarensis. And the fact that they lived around the same time, we can kind of see that there could have been like this shifting, and it's possible that when you get something like this, you get two completely, I shouldn't say completely, but different phylogenetic traits and morphology, that perhaps afarensis moved to a different part of Africa and required a different set of, or went through a different set of environmental stresses that provided the genetic shifting that's required in evolution. Just really interesting stuff. And this, just so you guys know, the study is from Haile Selassie, Esfazana, Benazi et al. And in 2019, a 3.8 million year old hominin cranium from Oranzomil, Ethiopia, and was published in Nature. And that was just published in August of 2019. More of what that really says is they found a nearly complete skull of an early hominin. It also says that it's different. It really differs more than they expected than the skull of a similar find in Australopithecus afarensis. And as I said, they lived at the same time. And if we think about Australopithecus afarensis in specifically, they're saying that they lived basically 3.5 to 2 million years ago. That's a huge time frame. That's 1.5 million years that this species roamed Africa. They never really got out. But think about how long Homo sapiens have been around, or Homo sapiens sapiens, the wise man. Over 250,000 years, we have populated pretty much every corner of the globe. It's just an incredible biological success story. The way that humans really fully developed into what we know today. But yeah, just wanted to get that out there. And I wonder, because these two species lived at around the same time, kind of just like humans and Neanderthals lived at around the same time, Neanderthals and humans were able to reproduce between species. So we have, cross speciation, which is really cool because the European people of European descent, I mean, there's a halfway decent chance that you might have Neanderthal DNA in your genome, which is really cool. And it's possible that if these two lived at the same time, and if they lived close enough, which, I mean, evidence does suggest that the area in which they lived kind of crossed paths, that they could possibly also have been interspecies procreation, which is so cool. Perhaps one day I'll do a full series on this topic and the history of hominin evolution. If you guys want me to do that, please hit me up and I'll try and make it happen. It'd probably be really long and really boring for some of you, so I don't want to do that if it's not something you guys are interested in. So let me know. I do want to focus on this single aspect of our ancient humanity, but to do that, I do feel it would be a disservice to you guys to not give you kind of a rundown of the timeline and how, as humans, we kind of fit into this. All right, real quick. Sahelanthropus chadensis, he's the oldest one. This is going to be the oldest form of bipedalism that we have, or presumed bipedalism. I mean, you're talking about, I mean, really archaic in morphology and traits. Then the next one, we have Ardipithecus cauda, and Ardipithecus cauda is probably our oldest living ancestor. The Ardipithecus, Australopithecus, they kind of form that they fill in that niche of that oldest living ancestor, probably, and that's why Australopithecus anamensis, the most recent one, isn't most likely our oldest ancestor that we've ever found. So we have Chadensis cauda, and then we have Ardipithecus ramidus, and then we have Australopithecus anamensis, which is the one that I'm talking about today. Australopithecus afarensis, which is the Lucy skull, right? And up to this point, so Chadensis was like 6.5 million years ago. Ramidus was 4.5+ million years ago. Anamensis was like 4.2 to like 3.8 million years ago. And afarensis lived a really long time. That's like 3.8 to like, 2.5, 2 million years ago. Really cool. Australopithecus africanus, which is like 3 to 2 million years ago or so. And then we have something really neat. We have the very first species of Homo, the very first genus Homo, showing up at about like 2.3 million years ago, Homo habilis. And then we have the larger, we have Homo ergaster, Homo erectus. We have the pygmy people, the Homo floresiensis, Homo sapiens, and Homo neanderthalensis. So pretty cool. And the Homo species, like I said, about 2.5 million years ago up until today. Homo floresiensis was, around pretty recently, while humans have been around. Homo erectus really started going extinct around the same time Homo sapiens came about. And this is where we think that perhaps Homo erectus is a very closely related near ancestor to us. And then we also have Homo neanderthalis, which went extinct definitely during Homo sapiens, run in the evolutionary table. That's a really cool story about how they could have gone extinct. There are a lot of different theories out there. Oh, I forgot Homo heidelbergensis, which is about 500,000 years ago. So hopefully that didn't confuse you guys. I do have a table, a picture of hominid evolution on my website. You should definitely go check it out. It'll make whatever I just said, it'll make it clearer. And then I also have a video that was done, I think, by the Smithsonian Institute on the website. Also gives you some really good information, more than I wanted to give in just that short, brief time. Here we go. So basically, there have been some form of bipedalism, bipedal great ape, walking the planet almost continuously. Now, I mean, obviously not the same species, but from almost 7 million years ago until today. 6 to 7 million years might seem like a long time, but there are certain species alive today that have gone several million years without much change. Unlike the great apes, including humans, which seem to be constantly adapting to the environment. I wonder where the next 7 million years will take us and how our genus will develop from here. Some of the more interesting ones that have kind of gone mostly unchanged for a really long time, and we've heard this a lot, crocodiles, they've gone mostly unchanged for 150 million years. That's not exactly true. 3 of the more interesting ones, lesser known ones, we have possums, lice, and platypus. The platypus is very archaic in the way that it's designed. It's super weird mammal with a bill and lays eggs. I don't know what the heck is going on there. I won't link anything here on my website because I do think it would be fun for you guys to do your own research. The stories that these animals represent are really fascinating, and I think you guys would gain a lot by doing some research on your own. So like I said, crocs, possums, lice, and platypus. But back to the reason we're here today, Australopithecus anamensis. And I have pictures of him, I'm going to call him Bob kind of from now on, but I have pictures of Bob on the website, or reconstructions, as well as the fossil remains. Do you guys know about Lucy? Lucy was the find of a century, or millennia really. Her skeleton was 40% intact, and it provided a unique gateway into understanding some of our earliest ancestors. It was thought that our skull, Australopithecus anamensis, or Bob, was the ancestor of Lucy. The new discovery kind of throws that into a little bit of a turmoil, but it shows that just a small piece of the overarching puzzle. It shows the complex nature of evolution and our ancestry. What can we tell about Bob from his skull? We can tell quite a bit, and the following I am going to quote directly from a great Washington Post article about the new skull and its find by Ben Guarino. Is very rich. It's a very rich recreation of expert testimony and research, and it's worth sharing with you guys. So this is from Ben. The primates sorted a mixture of traits, both primitive and human-like, or archaic and modern. The species almost certainly walked on 2 legs, and they had long arms, strong hands, and that suggested that they were capable climbers. The older Australopithecus left more fragmentary impressions, so the finds before this new skull. And these were kind of reduced to an arm, a handful of teeth, partial jaws, other bone scraps. Its skull had long eluded researchers. The new fossil is the most complete, earliest Australopithecus skull ever found. That's really exciting, said Carol V. Ward, a University of Missouri professor who studies the evolution of early hominins. As I said earlier, hominins are humans and our extinct relatives who split from the rest of the great ape lineage about 7 million years ago. This is the fossil I've been waiting for, she says. Ward, who has studied Australopithecus anamensis since the 90s, soon after paleoanthropologist Meave Leakey and her team named the species, said skulls are rich in information. They house the brain and most of the major sensory systems. They reflect locomotion and body size. The jaws can inform scientists about an extinct species' diet. The specimen could help refine the timeline of adaptations. She said that Australopithecus anamensis has a smaller, somewhat differently shaped brain than Lucy or Australopithecus afarensis. This skull is the first to give us a glimpse of what the face of Australopithecus anamensis looks like. We really wanted to know what Bob looked like, Holly Salisi said, who is the main author of this. He was the main author of the paper. It had a jutting jaw and lower features, and over millions of years, hominin faces flattened while the brain case enlarged. So our faces moved in, right? They moved in closer to the interior, and as it did that, the evolution started pushing the back part of the brain and the front part of, these skull fragments more vertically, allowing for larger brains. A lot of people ask, well, when did we start looking more like ourselves? And I would say that starts with the origin of the genus Homo, which I talked about earlier. If you remember, Homo habilis lived about 2.2 million years ago. That's when they first show up in the record. The features of the skull also allowed researchers to tease out the relationships between these extinct hominins. We identify species not entirely, but largely from the jaws and the teeth. The jaws and teeth and cranium, and use that information to sort out how they are related to each other. From this specimen, which represents the oldest Australopithecus species, we can better start to address why Australopithecus first evolved. It's an early marker on the evolutionary path. For the past decade, the generally accepted idea, Strait said, was that Australopithecus anamensis transformed over time into Australopithecus afarensis, following it in sequence, kind of like dancers in a conga line. Or if you remember, when some people think of Darwin and the dawn of man, you think about that stretch of great apes into more archaic humans and into Neanderthals and what we think of cavemen, and then is what we think of modern humans. But this idea is really, this discovery is really challenging that idea. The authors of the study suggest that an isolated population of hominins split from anamensis and evolved into afarensis. In this view, Lucy's ilk, the afarensis, was an offshoot species that did not immediately replace its predecessor relatives, but lived contemporaneously. They lived together. The strongest evidence in favor of this explanation is a bone fragment reported earlier, this one from another region in Ethiopia. The fragment, 100,000 years older than the newfound skull, has a forehead that is wider behind the eye sockets. This trait, the authors say, means it belongs to Australopithecus afarensis. Put another way, there may have been a period of about 100,000 years when they both lived. Not everybody agrees with this. Tim White, a paleoanthropologist at the University of California, Berkeley, disagrees. No two crania of any species are exactly identical in all anatomical details, including our own species, as well as our closest living and fossil relatives. He interpreted the difference in measurement of the new skull and the skull fragment as variation within a single species, Australopithecus anamensis. This discovery is therefore a great example of a very important fossil that does not require a redraw of our family tree, but rather strengthens the hypothesis that Australopithecus was evolving between 3 and 4 million years ago. Ward, who we discussed earlier, was also skeptical, pointing out that the study's author's hypothesis hinged on an incomplete bone fragment. I know that was kind of a lot, but I am happy that I got to share one of my passions with you guys, and would be more than happy to talk about this, like I said, in more depth if you guys want. But this has been an episode of the Uncensored Podcast Network in affiliation with History Uncensored and The Science Solution. Please make sure to check them both out. And if you want to get a hold of me, reach me at Twitter. That's Seth4Nerds, at Seth4Nerds, as well as my email address, contact@historyuncensoredpod.com. Look for more information on my website. And I just wanted to put this out there. Without you guys, without listeners, I couldn't make this podcast possible. And I appreciate all the support and listens that have been given to me. If anyone is interested, please rate and review the show wherever you can. And any feedback you provide is more than welcome, even if it's bad. If you think there's something I can improve on, I'm still very new. I understand that, but I am more than happy to try and fix any flaws that I do have. Unless it's my voice, I can't fix that. And if you don't like it, I'm sorry. As always, think science and be kind, and history remembers. Again, this has been Seth Michaels. I hope you guys have a wonderful day.
He knew the world would not be the same. Few people laughed. Few people cried. Most people were silent. I remembered the line from the Hindu scripture, the Bhagavad Gita. Vishnu is trying to persuade the prince that he should do his duty, and to impress him takes on his multi-armed form and says, "Now I am become death, the destroyer of worlds." I suppose we all thought that one way or another.